In question 8a, a cyclist completes a long distance charity event across Africa. The total distance is 3,050 kilometers. He starts the event on May 1st and cycles 200 kilometers on that day. On each subsequent day, he reduces the distance cycled by 5 kilometers. In part 1, we have to find how far he will travel on May 15th. Now, as he is reducing the distance traveled by 5 kilometers, it means that it is an arithmetic progression, as is a common difference. So as it is reducing by 5 kilometers each day, it means that d will be equals to minus 5. And as we have to find the distance it travels on May 15th, so it means we have to use the nth term formula, which is a plus n minus 1 into d. As on the first day, he traveled 200 kilometers, so a will be equals to 200. So finding the 15th term, it will be 200 plus n minus 1. So that will become 15 minus 1 and d is minus 5. So minus 14 into minus 5 is 14 into minus 5 is 70. So 200 minus 70. So that will be equals to 130. So he will travel. So 200 minus 70 will be 130. So on the 15th day, he will travel 130 kilometers. In part 2, it says on what day he will finish the event. Now, as he has to cover a total distance of 3,050 kilometers, so we'll use the sum formula, which is sum of n terms is n upon 2 into 2a plus n minus 1 into d. Now, as the total sum of the distance he travels will be 3,050 kilometers, so this will be 3,050 equals to, we have to find n, so this will mean n upon 2 into 2a, a is 200, plus n minus 1 into d is minus 5. Cross multiplying, so 3,000 into 50 will become 6,100. Expanding the bracket, this will become 400 minus 5 into n is a minus 5n, and minus 1 into minus 5 is a plus 5. Simplifying the bracket, we'll get n into 400 plus 5 is 405 minus 5n, and this is equal to 6,100. Multiplying n by the bracket, we'll get 405n minus 5n squared equals to 6,100. Taking 5n squared and 405n on the left hand side, this equation will become 5n squared minus 405n plus 6,100 equals to 0. We can divide this equation by 5 and write it as n squared minus 81n, and 6,100 divided by 5, that is equals to 1220. So that will become n square minus 81n plus 1220 equals to 0. Factorizing n squared minus 81n plus 81n plus 120. So factorizing this will be n minus 61 and n minus 20 equals to 0. So the two values of n will be n equals to 20 and n will be equals to 61. Now we have to decide which of these values of n to take, as both of them are giving the sum equals to 3,050. But if we take 61 n as 61, in that case our terms will become negative. So as we are starting from 200, it will keep on decreasing by 5 kilometers each day. So if we take the 61st term, the value of the distance traveled will become a negative. So the value of n that we'll have to take is n equals to 20, as when n is 61, the distance traveled will become a negative. So distance traveled on that particular day will be negative. So we will not be taking n equals to 61. So this will become a negative. Now in part B, it says that a geometric progression is such that the third term is 8 times the sixth term, and the sum of the first 6 terms is 31.5. We have to find the first term of the progression. Now, as the third term is 8 times the sixth term, so we can first write this as, so the third term, the nth term of a geometric progression is given by ar to the power n minus 1. For the third term, the formula will be ar to the power 3 minus 1, which is equals to ar squared. And the third term is 8 times the sixth term. So for first finding the formula for sixth term, that will be ar to the power 6 minus 1, which is ar to the power 5. Now making a mathematical equation, as it says that the third term is 8 times the sixth term. So we can write this as the third term equals to 8 times the sixth term. A and A will cancel. R square will divide by, so we can take 8 on the other side. This will become 1 upon 8 is equals to R power 5 upon R squared. So this will cancel out. R cube will be equals to 1 upon 8. And now taking the cube root of 8, so the value of R will be 1 upon 2. Once we have the value of R in part 1, we had to find the first term. So to find the value of A, it says that the sum of the first 6 terms is 31.5. Now the sum formula for n terms of a geometric progression is given by A into 1 minus R to the power n upon 1 minus R. The sum of the first 6 terms was given as 31.5. So we can write this as 2 into 31 is 62. 62 plus 1 will become 63. So this will be 63 upon 2 is equals to A into 1 minus R is 0.5. So we can write 0.5 to the power 6 divided by 1 minus 0.5. Cross multiplying, so 63 will multiply by 0.5. So this will become 63 multiplied by 0.5 divided by 2 is equals to A into 1 minus 0.5 to the power 6. So 1 minus 0.5 to the power 6, that is equals to 0.98. 984,375. So dividing it by 2 and then 63 into 0.5. So this will, the value of A will be equals to 16. Substituting this in the calculator, we can write that A will be equals to 63 into 0.5 and divided by 2 into 0.984375. So the value of A will be 16. Once you have the value of A, in part 2, it says find the sum to infinity of the progression. For sum to infinity, the formula is, so for sum to infinity, it is A upon 1 minus R. The value of A is 16 and the common ratio R was equals to 1 upon 2. So 1 minus 0.5. So 16 divided by 0.5, the sum to infinity will be equals to 32.